Okay. There you go.
Why are you so naughty?
We have dress up to my ankles. Up to my ankles.
Mason, don't start.
There you go.
Don't start.
All yours.
Okay.
Fire away, it's all yours. PowerPoint? What am I doing? It's okay. Amateur hour is here. I didn't even have it open in front of me.
Where's like a dollar?
So guys, what'd you talk about yesterday?
We talked about a three-step equation.
About what?
A three-step equation.
A three-step equation. Okay, we're stepping it up a little bit now. 3 steps. Today we're going to introduce something a little bit new. 4 steps.
Oh yeah, that's what we were doing.
What?
Yeah, that's what we were doing.
You were doing 4-step equations. Well, today we're going to be not increasing the steps. We're going to be getting a little bit more basic again, but we're going to change the problems a little bit in a different way. In the problems we had before, we would have variables on one side of the equation, and we would just isolate that variable, get it all by itself, and solve for it. Now we're going to be doing things a little bit more complicated, where we have variables on both sides of the equation, where we have a variable on both sides of the equation, and you still got to get that variable all by itself. So the new piece of information kind of here will be getting those variables together. So section 4, solving equations with the variable on both sides. So we're going to be working on problems like this, where we have a 5x on this side and a 4x on this side, and our goal, what is our goal in all of these problems? Pretty much no matter what they look like, what's our goal? We want to solve for x. We want to get our problem, eventually at the very end, we want to get our problem to look like this, where we have x equals something. So we want to have just x on this side and just a single number on that side. Even if our problem looks like this, this is still our goal. Is it 10? It sure is. So in this problem right here, what is kind of our first step? What is one of our goals here? We want to move the 4x over, yes. Kind of the new thing that we have here in this problem is we have x's on both sides. We're going to be dealing with variables in multiple different places. Even though we are dealing with variables in multiple places, we have a variable there and a variable here, our goal is still just to have one variable. So we want to combine those variables. We combine them, they're like terms. We would combine those like terms just the same way we would combine that 8 and that 2 to get 10. So if we take 5x minus 4x, what do we get? 1x. So we get 1x minus 8 equals 2. Now we're back to a problem that we've worked with kind of before, where we just have one variable, it's all by itself, and everything else is just a normal number. So what do we do from here?
Add 8 to 2.
We want to add 8 to both sides. Yep. So we get 8x equals 10.
You may or may not have done this yesterday.
May or may not have. You did do this yesterday? Okay.
Always, yeah.
Any questions on this problem right here? Okay.
Always, yeah.
So for this problem right here, we have 21 minus 4k equals 9k minus 18. So, what? Oh, you did these exact problems yesterday? Okay. I think you did like 3 slides. Did you do this slide, these problems?
Yeah.
Okay.
Yeah.
Yeah, we did that one too.
Yeah.
Okay.
We did that one too.
How far did you guys get?
Quite a ways. I didn't write everything down, but I got some down.
What?
Alright, let's just start here anyways. Some of this might be a review, but let's keep going anyways. It's good to get some more of this practice even if we've done these problems before. Here we have 2g plus 3 equals 3g minus 2.
5.
What's that?
That's 24.
So what is our first step in this problem? Even if you know the answer, I still want to go through this step by step.
Well, we gotta put the 3G onto the, you gotta switch to 3G, the two threes, you gotta switch to two threes. Yeah, to the side.
So
You gotta flip them.
our goal in these problems is to combine our like terms. We want to combine our g's and we want to combine our constants, our just plain numbers. So our goal is to combine those, get those numbers together. So let's subtract 2g from this side, subtract 2g from this side. So then we have 3 equals 1g minus 2.
Oh, great.
Then we can add 2 to the other side.
5.
G equals 5.
Let's go. I said 5.
So in this problem right here, what's our first step?
Like terms.
We want to combine our like terms. What like terms do we want to combine?
Oh. P with the 15, you flip them.
We can subtract that p. So you get 6p, or no, 4p.
Wait, what? Oh, it's the P of 1.
Yes, remember that whenever we have a variable all by itself, there's just one of them. Whenever we got a variable by itself, it's just one. There's one of them. So we either got that coefficient 1p, subtract p from both sides, 5 minus 1 equals 4p plus 15 equals negative 49. What's that?
I don't know.
You know? Okay. What do we do from here?
Oh, Right? There's no other P on there, so you just do 15.
Yep. Just subtract 15. We got our piece together already. So we just subtract 15 from both sides. Guys, what is Guys, what is negative 49 minus 15?
I don't have a calculator.
54.
You should figure that out.
Doesn't take a genius.
I should do
Negative 54. Now we got to divide both sides by 4. Still want to get our variable all by itself. So negative 54 divided by 4. Grab a calculator if you need one. What is this answer?
12.
What's that?
12.
No, it's not. Nope.
Where'd you remember?
What's the operating moments? Where are we at? Okay.
What are you doing?
I want to know what negative 54 divided by 4 is.
Oh, that would be. What are you doing?
Negative 13.
Negative 13 and a half?
It wouldn't be a decimal.
I don't think so.
I did negative 54 divided by 4. I mean, unless I typed it in wrong.
13 and a half.
Yeah, it is negative 13 and a half.
Oh, okay. Yeah, you're right. Negative 13 and a half. I was thinking that was a 56 for some reason. My bad. All right.
Actually, be happy instead of getting mad at me. I got those. I classified it.
Okay, so the new piece here, what all is kind of going on in this problem? What do we got going on in this problem right here?
The parentheses.
We got parentheses. We do got math going on.
2C and 2 times 6.
And then
What are you saying we do?
it's 1.
2C.
So you're saying we multiplied the 2 by the c and the 2 by the -6. What are we doing when we multiply that 2 in both those places? We're distributing, yes. In this problem, kind of the new thing that we have going on is we have to distribute. So we have, if we do distribute, we get 2c minus 12 equals 9c plus 2.
No.
Now what do we want to do? We want to get our variable terms together, so I'm going to subtract 2c from both sides. So I get -12 equals 7c plus 2. Now that I've got my variables together, I want to get everything away from the variable.
-2.
I want to subtract 2 from both sides, yep. So -12 minus 2 is going to be a -14 equals 7c. Divide both sides by 7, and I get c equals -2. Dark, head up, please.
Oh, I see.
Morning.
2. What is that? 4. Alright.
Alright, I want everyone to do this problem, and then I'm going to call on someone to help me. So get out a piece of paper if you need one. Probably not something you can do in your head.
You guys talking about over there.
Yeah, right. I gotta listen to it.
So you take,
Thanks for calling you.
wait, did you call him Ray?
No, I didn't. I haven't called on anyone yet.
You can call Mr. Ward. Mr. Ward's in the Ray.
Dark, head up, please. Wake up. I want you, everyone to do that problem. Reese, walk me through this problem right here. What do I do first? I don't know. I don't know what the answer is.
3 times 6.
We want to distribute, so we'll take 3 times 6. What is 3 times 6? 18. Now what?
3 times 2.
What is 3 times 2? 6. And just rewrite the rest of the problem.
Move the 10.
We can move the 10 over. So we can add 10 to both sides to get rid of it. So we're left with 8y equals 28 minus 6y. Now what do we want to do?
Add the 6, 8, and 6.
We can add the 6y. Yep. So that gets rid of our -6y right there by adding it. We're getting rid of that. So we get 8y plus 6y is going to be 14y equals 28. And now what's our last step? Divide 14 from both sides. Y equals 2.
Yeah.
Any questions on this problem right here? So our very first step was we distributed to get rid of those parentheses. We can't touch what's inside of the parentheses until the parentheses are gone, so we got to distribute to get rid of those. We distribute the 3, and then from there, we want to combine our variable terms and combine our non-variable terms. This problem right here, I want everyone to work on it, and then I'll call someone to help me out. Sam, walk me through this problem.
Take the 3 times 2x, which is 6x, and then take the 3 times 4, which is 12.
Yep, so we want to distribute. That's our first step. Get rid of these parentheses.
Good job.
Can't touch what's inside of that parentheses until they're gone. So 6x plus 12. Other side just stays the same. AJ, what do I do next?
Move the 6x over to 4x.
So you want me to subtract 6x from both sides? What is 4x minus 6x?
2x.
We're going to have a negative 2x plus 18 equals 12. Elliot, what do I do from here? Yep, we want to subtract 18 from both sides. We want to get our variable term all by itself. So we got to get rid of that 18 that's being added to it. So we're going to have a negative 2x equals 12 minus 18 is going to give us a negative 6. And then Sam, what do we do last?
You're going to do negative 6 divided by negative 2, and that's 3. It actually gives 3.
We're going to divide both sides by negative 2 because we're still trying to get our variable all by itself. So getting rid of what's around our variable, x is going to be equal to 3. What questions do you have on this problem? It's what?
It's really difficult.
It's really difficult. I see that.
Quiet then.
Too easy?
Quiet then.
You want me to ramp it up?
Oh yeah.
Yeah, please.
Goodbye, Sam.
Do it as
Goodbye, Sam.
Oh yeah.
Oof, the yes.
There we go.
And
love this.
Actually, it's pretty much the same.
That's pretty much the same.
Pretty much the same
All you
thing?
gotta- all you gotta do is divide 1 by 3.
Oh,
You take that, once you take that, you gotta go move.
Whoa, start again. What do I do here first?
You swap the 4 and the 10, two of those.
Swap the 4 and the 10?
Yeah. And then you take 1 divided.
What do you mean by swapping the 4 and the 10?
Like you move 4 in the place of 10 and 10 to the place of the 4.
1/3 x. What do I have right here?
Plus 4x.
Plus 4x?
Minus 4.
Minus 4x.
Yeah, because you switch.
Minus 4x. And then what do I have over here?
So you have
Negative 10.
Yeah, negative 10.
Remember that when we move things to the other side, we got to change the sign on them.
Yeah.
If we have a negative number and we're moving to the other side, we got to add it. If we have a positive number and we're moving into the other side, we got to subtract it. Remember, that goes back to our inverse operations. So what is 1/3 minus 4x?
So what you gotta do? 0.3.
One-third x minus 4.
Negative 3.6 repeating and 7.
It's going to be a negative 3.6 repeating. And what that tells us is that it's going to be a negative 3 2/3. Negative 3 2/3 x, remember we got a mixed number there. We're dealing with fractions, so these kind of things will come up. Negative 3 2/3 x equals, what's negative 10 plus 5?
That's 5.
Negative 5.
Negative 5. Let's be careful about our signs. And now how do we get x by itself here?
3 times.
5.
We got to divide both sides by negative 3 2/3. So guys, remind me, shh, in this problem right here, we have a number being divided by a mixed number. We have a number being divided by a fraction. How do we do that?
1.3.
What's that? What's that?
Oh, shoot. Oh, I need to connect it.
How do we divide by a fraction?
2 divided by 3.
What's that?
2 divided by 3.
Negative 1.3
1.38
repeats.
repeating? Okay.
Like that.
So guys, remember that back to middle school, whenever we are dividing by a fraction, what we really want to do is we want to flip our fraction and multiply. So when we flip our fraction, how can we rewrite this fraction or that mixed number as a fraction? We want to rewrite this mixed number just as a fraction. Yeah.
3 times 3 plus 2.
Yep. 3 times 3 plus 2 is going to give us 11. So we have 5 divided by 11/3. And now how do we do that right there? If we divide by a fraction, what is a quick shortcut that we can do? What's that? What's that?
I usually do 11 divided by 3.
We can do that. We can take 11 divided by 3 and that's going to give us a gross decimal. And then we have to take 5 divided by that, but there's a shortcut here that we can do.
Oh, so can you do like 5 divided by 11?
Could you do
Or do you have to multiply it?
5 times 11 divided by 3?
When we divide by fractions, what we can do is we can flip our fraction and multiply. That right there. Does this ring a bell?
Oh, you just flip it around.
Rings everything.
Okay. So when we divide by a fraction, we can just flip our fraction and multiply. So we take 5 times 3 gives us 15 over 11. Our answer is going to be 15/11ths.
Now can you reduce that?
We can't reduce it, but we can figure out what that decimal is.
All you do is just 5 times 3, that's it.
Yeah.
5 times 3 divided by 11 gives us 15 over 11.
1.36363634.
1.36 repeating, or 6.3 repeating. 3.6?
3.6 you're on when it's
Yeah, it goes 1.3636.
Okay.
Good point.
So whenever we're working with fractions like this, we want to be really careful about remembering our facts about fractions. They will come up here again. So we got to know how to combine our like terms. We need to know how to add and subtract by fractions. And we got to remember how to multiply and divide by fractions as well. Because whenever we plug things in a calculator, things get really, really messy. We're going to be dealing with decimals and repeating decimals, and those are going to be things that are going to be hard to plug back in and use. So if we can remember these kind of facts right here about our decimals, that's going to make these problems a whole lot less messy. So this problem right here, what do we do first?
Well, remove the 1.5, it's plus into the half minus, so we do that one plus, finish 7 to the negative, and that one
So guys, for this problem right here, instead of just subtracting our 1/2 and then adding or subtracting the 7, instead of combining our like terms that way, there's something that we can do to this problem from the beginning to kind of make our lives easier. To get rid of this fraction to make this problem easier for us. So what I'm gonna do is I take a look and see what this fraction is. It's 1/2, it's 1/2. And what I wanna do is I don't wanna have to deal with fractions. I think fractions get messy, then we have to kind of remember some of our operations with fractions, and those can be a little bit more difficult, and then we have to work with decimals in the end. And we can just take steps at the very beginning of the problem to make it so that we don't have to do that. So I'm gonna take whatever this is, whatever that number is, and I'm multiply the problem by it. So that will be our second step here. Our first step, I wanna add 5 to both sides. So I'm gonna get 2x plus 12 equals 1/2 x. Now what I want to do from here is I want to get rid of that fraction. So what I'm going to do is I'm going to multiply both sides by 2. Multiplying both sides by 2 will get rid of that fraction. If I multiply both sides by 2, that we suddenly don't have fractions in our problem anymore. So if I multiply 1/2 x times 2, I'm just going to get 1x. Shh. If I multiply 1/2 x, I'm just going to, by 2, I'm just going to get x. That was kind of our goal there. And if now, what I do to one side of the equation, I have to do to the other. Remember, an equation has that balance going on. What we do to one side, we have to do to the other to keep the things truly equal. So now we have 2 times 2x plus 12, and we can just distribute. So 4x plus 24 equals x. So now all of a sudden, with that step right there, we don't have fractions in our problem anymore. It's going to make our problem overall easier to deal with. So what do we do from here? Now we have 4x plus 24 equals x. What's that?
Divide.
Not quite yet.
Subtract the x for 4x.
I got to combine my x terms together.
Or the other way.
So I'll subtract my 4x from both sides. So I get 24. 1x minus 4x is going to give me a negative 3x.
8.
Then I can divide both sides by negative 3 to get my x all by itself. Then I get x equals negative 8.
Negative 8. I see.
So in this problem right here, we did kind of one extra thing. We did one extra thing or one thing different. What we did was we multiplied both sides by 2 in order to get rid of our fractions. Anytime you guys have fractions, you can do this step to make the problem easier to work with. Because most of us don't like working with fractions. It's just a fact. It just makes it harder to plug in to our calculator. It's easier to make mistakes. Then we get decimals, and it's just a messy process.
Can you do this another way?
Do this another way? We can do this the way that we did it before. Would you like to see that?
No. We just switch.
Huh?
Yeah, no. We could just keep it going.
Do you,
Next question.
okay. Are you sure?
Yeah.
Okay. We'll do another one like this to practice. In this problem right here, we have 2/3 h plus 4 equals h minus 1. We want to get all of our variable terms together, and we want to get all of our consonant terms together. So what do we do?
Bring your head towards my
It's a random.
joking, I don't even know how to do this.
What questions you got?
Stay in here.
No, I'm gonna fail this.
No, you won't.
It's like the exit ticker or something.
Homework.
Hey!
So you guys got the rest of the class period to work on this?
What are you trying to say?
I got it.
Walk.
Benjamin, I want to see blood.
Yeah, start yelling out.
Guys, I want this by the end of the class period.
Homework.
Yep, I misspoke, I'm sorry.
How much time you got?
You got 10 minutes to work on 4 problems, you got plenty of time.
Oh, I got the other.
If you guys have questions, let me know.
Could it be a decimal?
Benjamin.
It might be.
First one, isn't it -9?
The first one?
What's that?
It's made in 1900.
He reminds me of it. He does. I watched his dog.
No.
There's a video of it. It's like,
Calculator.
Number 1, what did you say you got?
No, a calculator.
and
No, it's more.
Yes.
no.
No.
His dog was saying, video and sent it to me.
Okay, what is it?
Close to that. Make sure you plug in your calculator right.
Abraham.
I don't know his address.
Abraham.
Or you will not.
That's an easy one that you said, Jess. Ooh, just
Got the answer.
Mr. Stein.
Yep. Yep.
That's right.
It's not my fault that you don't pay attention.
You will not get any decimals.
That's the answer.
-17, right?
It sure is.
Hey, can I see that paper?
This one?
I don't know.
Hey, Benjamin, what's the first one? There you go.
I'm on a race, so you better be. If I don't see the work, I'm not gonna give you credit. It
Oh,
just
it's
comes
just,
down to that, so. Yeah, put the work down. I mean, if I don't see the work, I'm not gonna give you credit. So. It's
Hey,
as simple as
Benjamin, is
that.
number 2 -3, eh? No, -3. I mean,
Or is it just 3?
it's gonna be -3.
What questions you got for me? 2 -3.
It is.
It's gonna be a +3.
Yeah, I was right.
Yeah, I think.
You guys need help?
No,
You just always want 3.
Because we're just.
I don't have GPs for you guys, are easier than stuff like right now.
Is it 17?
It's like a little like progress bar or check for understanding.
If we
It was a
don't,
great ad.
Why's your motor jack
if we
down?
don't,
But only class period. You got 5 minutes. So,
but so my next period, I made like a class on Tuesday.
It's not level.
So that's why I got the last
Just
assignment,
something to work.
because I know you guys
Okay,
Otherwise,
that's
I
fine.
wouldn't have done it.
Yeah, that's fine.
It's gonna be negative anyways.
How's this 3?
I got negative.
I don't know her name.
I got it.
The other side.
Yeah, I'll buy this.
So you get 10A minus 14 equals 16. Then you add 14 to the other side.
What am I supposed to say?
14 to the other side. So
I know I'm wrong. I
10A,
don't know what to do.
then 16. This is positive 16, that would be a positive 14. So positive 14 plus positive 16. Yeah. 16 plus 14. Fine. Yep.
It's negative 14, right?
I forgot that it was.
I thought it was negative 14 or 16.
What is
So
I thought it was a teacher's name.
subtract 6 to the other side, so you're left with just 1r. So 1r minus 13. Then you gotta do, or plus 13.
It's 3? Yeah, it's 3? Negative 4.
I don't want to show my work.
1r plus 13 equals negative 4. Subtract the 13. Yes.
I was right. Oh my god.
Hey,
You won't get
Yes.
thanks, Lord, for the name.
That sucks.
Alright, thank
No, dude, actually, don't say the Lord's name in vain.
My
Gosh,
bad.
Alexis.
51.
I think I figured it
Sam, you
out.
don't even go to church.
I get something.
It's negative,
Yeah,
is
that's
it, is number 3, no, it can't be a decimal, because we said no decimal.
What's stupid? Answer number 3.
I don't know how to do it.
You said you did.
What is
This thing is messing with my head.
8, 9, 10.
Where'd you get 21
That's
from?
4 1.
Tap it right here.
That's 4 1.
Okay, so negative 21. What is negative 21 divided by negative 3?
It's 4 1. It's 4 1.
No.
Whoever has the incident started today.
Is that just you?
Why'd you get negative? I don't understand how you got negative 3.
Yep, that means it's 1.
I thought it was
I just let it sit down. Mine's good.
Yeah. 7. Negative.
You're crying it out over.
I would. My best.
Especially now with the time.
Oh my god.
Yeah. I got it.
Better be right.
Me?
I got it.
I'm not there yet.
It's 3 3.
Is it
I'll
7?
finish this.
It is 7.
There you go.
I'm dumb.
Edwin.
I had 7.
So
stupid.
So dumb, Abraham. God. I don't know. I just did it all of a sudden. Now apparently I'm doing it right, so I'm just gonna keep doing what I'm doing.
What?
You're fired.
That's good. I don't gotta work.
No, you cannot. No, please, no. I don't want to know what you would send it.
You only have like a minute.
Well, I'm not done.
Hello.
Is it 4? Is 4 4?
That's not man.
It is. It's 4.
Let's show your answer.
Taking that long, Abraham?
It was easy. All you gotta do is just. Here you go. 4 was the easiest one. Why is that?
Oh, wait, was it negative 19? Oh, okay. Oh, negative.
What?
Here.
Alexis, I said yours.
So we're good. Oh, Mason.
Gosh, Alexis, just catch it.
I didn't know he was throwing. Okay, Sam. You know what? Leave me alone.
Oh, you know Friday when you
No.
went over to Carly's house? Me and your sister had a good talk.
Yeah, that's one.
Oh, how old's your sister?
No.
Oh my god, she's like 7.
Oh, Sam, that's the young ones.
Ew.
You're gonna have some other
I don't even
siblings.
know. What are you telling
You
them?
know,
be a
I asked her
boss.
if she had stolen all your money and candy from you, and she said, I never stole anything from my sister, and I said, go start stealing.
You liar.
I said, start stealing.
You're gonna be a mom.
Ever get that sheet turned in?
Mr. Gar, you were called the office.
No, I think you're saying. Yeah, no, she's about yay high. Then she asked if I was going to her house.
The day's doing it. Oh, yeah.
Who did? Sister did.
Are you gonna go to